Everyone, welcome you all to this video. From today onwards we are going to start this topic, sequence. In fact, we will study sequence of real numbers. Fine. Sequence of real numbers. And you know that this topic, it is very much important for any competitive exams like NET, GATE or any Ph.D entrance exam. Definitely they will ask question from this area and you have to make yourself comfortable with this topic. That's why our main aim of this series will be to focus on the necessary concepts, theorems, results and their discussion. Whatever necessary concepts we will study along with their application, those will be very much important to tackle the questions. Okay, so we will have Q&A, that is question and answer session regarding all these necessary concept, theorem and results. Okay, so stay tuned with us, and if you find the videos helpful, then I'd request you that you share. That is most important thing. Share the videos with your friends so that they can also notify and get few helpful information from this channel as well. Okay, so let's start with this topic, sequence. So basically, when we have sequence of real number, what actually it means? It means that you have a function whose domain is fixed and this domain is n, and the codomain is going to be a set of real numbers. So that is basically a sequence. So sequence means it is a mapping or function from the set of natural number to the set of real number in case of real sequence. But in case of complex sequence, that is real sequence. In case of complex sequence, you have complex sequence or sequence of complex number. You have this codomain as C. Okay, that is set of all complex number. This is the basic notion. Sometimes we denote this sequence by Fn or curly bracket Fn or Xn curly bracket Xn or like this way. Okay, these are just denoting style, and I think you are all familiar with these notations, and if you are not familiar with it, I would highly recommend you that the books what I already suggested to you, just go there and begin with it. You will get all this notation, and few examples will also study in this video, and more examples will be there in the book obviously. So I will request you that go there and study few examples that will make you more comfortable. So let's come back to real sequence, that is set of all natural number to set of real number function. Okay, for example, here I am considering, say, xn equals to 1 by n. Simple example. That means your fn it is 1 by n, correct? For n belongs to capital N, look at what you have: f1 as 1, f2 as half, f3 as 1 by 3, and so on, fn as 1 by n. So this is complete picturization of this sequence. So all these elements you have in R, but the input you have from N. This is basic notation, you can say. But if you are beginner to this field, then one question I will ask to you, that is there any pattern or is there any tendency of the elements? These are the elements: 1, half, 1 by 3, 1 by n, and so on, is there any common tendency to approach towards a certain number? Just think over it and definitely try to find out the answer, and it will match with our answer when we study the convergence of a sequence or limit of a sequence. Okay, just think over it. If you are beginner to this field, I am asking you this question. Okay, so this was one example, first example what we considered here. Now we will consider few more examples. Why? Because we want you to get familiar with various types of sequence. Now consider the second example. The second example, xn equals to n square. So you have the terms like 1 square, 2 square, 3 square, n square, and so on. Correct? Take another example. You have xn equals to minus 1 to the power n. So in that case, you have minus 1 plus 1 minus 1 plus 1 minus 1 plus 1, so on. Take another example. Xn equals to a constant quantity, say 5. So in that case, for n belongs to capital F, n you have 5, 5, 5, 5. Okay, a line of 5s are there. Okay, so these are few examples of sequence. You will get many more examples in the textbook, so go there and study few examples. Now one question is there, common question. The first example was xn equals to 1 by n. So the elements were 1 half, 1 by 3, 1 by 4, and so on. Okay, so a very common question it is that, is there any natural tendency of this sequence? Look at the terms of this sequence. All the terms are getting smaller and smaller, and it has a tendency to go towards 0. Fine. Okay, but in this case the terms are getting larger and larger, so it just simply blows up, that is goes to infinity. But here in this case, in the third example, you have for different values of n, you have this sequence fluctuating between minus 1 and plus 1. But here whatever value you just put, you are always going to get 5. Okay, so these are 4 types of sequence. The first one, it is example of a convergent sequence. Second one, that is, first one it is convergent sequence. Second one, it is example of a divergent sequence. Third one, it is example of oscillatory sequence. Fourth one, it is constant sequence. Okay, in fact this fourth one, that is constant sequence, it is a special case of convergent sequence as well. Fine. So all these are just introductory part, and I expect that you will study few more examples and make yourself comfortable with this topic. Fine. Now we are moving on to another type of representation style. Likewise, we have already studied this type of representation, that xn equals to something, it is given. Okay, but there is another representation style. For that I am taking an example, like the first term of that sequence, it is given as 1, second term it is given as 1, and rest of the terms are to be formed like this way: xn minus 1 plus xn, where n greater or equal to 2. So this is another representation style of a sequence. It is just an example. So first element may be given to you, and depending upon this first element, or this is example number 1, and say I am taking another example, that is first element it is given as 1, and rest of the elements, that is xn plus 1, it is f of x n. Okay, so here n starts from 1. Okay, greater or equal to 1. So these are just examples of representation of various kind of sequences. Fine. So here try to construct or try to write down this sequence explicitly, and if you know the name of that particular sequence, let me know in the comment section. It has a famous name of that sequence. If you know, let me know in the comment section. Correct? Fine. Now we are moving on to another important topic, that is limit of a sequence. Till now, okay, till this example number 2, we have only this introductory part. Now we are moving on to limit of a sequence. What do you mean by limit of a sequence? Correct? Okay. So limit means, suppose you have a sequence given as xn, and it has a natural tendency to go towards a certain number. Okay, say x. Okay, all the elements has a natural tendency to go towards x. So the nth term of that sequence is xn, and a particular number is there, and we will call this particular number as limit of this sequence. When here comes the epsilon definition, for epsilon greater than 0, and what epsilon is, it is however small you want. For epsilon greater than 0, you are always going to get, there exists k depending upon this epsilon, where k belongs to the set of natural number, such that the distance between xn and x, it can be made less than epsilon for all n greater or equal to k epsilon. What it means? It means that the difference between the nth term of that sequence and that particular number, say here we are considering sequence of real number, that's why this number should belongs to R. So this x, the difference between these two terms, that is nth term and this number, it can be made less than epsilon, and epsilon is however small quantity we want. Correct? Then we call this sequence goes to this number, and it is limit of this sequence. Correct? And particularly in that case, when you have this sort of thing, that as the sequence is approaching towards a particular number, okay, a particular number, then that sequence is called as convergent sequence. Okay, convergent sequence. A particular number. Okay, if there are more than one particular number, that is, the sequence have a tendency to go towards two numbers. Okay, say for example we have the third one. Okay, it has a tendency to go to -1 and +1. In that case, those two numbers are basically called as limit point. But for the case of first example, we have 0 as limit, and this first one was example of convergent sequence, and its limit was 0. But the third one, it is in fact oscillatory sequence, and it has two limit points, -1 and +1. These are the case for limit points. Okay, so don't get confused with these two terminology, that is limit and limit points. Fine. Now we have studied here this epsilon and k epsilon definition. Let's implement this definition here and how it works in this case for the first example. Let's check it out. Xn equals to 1 by n. Here we say that our limit, that is limit of xn n tends to infinity, it is 0. So it is as our x, correct? So for epsilon greater than 0, you have xn minus x, that is 1 by n minus 0, that is you are getting 1 by n, and your duty is to make it less than epsilon. So fine, you just put it like this way, xn minus x less than epsilon. But here what you are getting from this part, 1 by n less than epsilon. So n greater than 1 by epsilon, correct? So if we set our k epsilon like box function of 1 by epsilon plus 1, then surely it will be in the set of natural number. Fine. Look at this k epsilon totally depends on epsilon as well as it belongs to n. So this is our basic formation, that is for this epsilon greater than 0, we don't know what is epsilon, but it is known that it is a very small quantity. However small, we can think it is smaller than that quantity. For epsilon greater than 0, there exists this k epsilon which belongs to set of natural numbers, such that what we did, we can make this xn minus x less than epsilon for all n. This is for all n, for all n greater than this k epsilon. In fact, for all n greater or equal to k epsilon, where k epsilon is given as this one. So this is you can say the formation of limit of a sequence, and we call it like this way, that is the limit of that particular sequence is x, and in that case the example says that that limit is going to be 0. So this is just an introductory example, and you have a very important property, some very important property, and one of them is limit if exist. Okay, for a particular sequence, limit if exist, then it is unique. Right. So actually we are talking about convergent sequence. So for convergent sequence, obviously limit will exist and it is going to be unique. But in the case of non-convergent sequence, that is if the sequence is divergent, there is no question of getting any sort of finite quantity towards which the numbers are approaching. Okay, but if the sequence is oscillatory, obviously we may get some finite number towards which the numbers are going, but there will be more than one. So in that case we have oscillatory sequence. But in the case of convergent, obviously we are going to get unique limit. Fine. Okay, there are many more properties as well. Okay, and examples are there. Examples, study more and more example, and in the next video we will give you few more properties and concepts as well, and also we will solve few questions, because this 1 or 2 video will be totally you can say concept oriented videos. Then we will handle the questions asked in NET, GATE or any competitive exam. Okay, so that you guys will find these videos very much helpful and make yourself comfortable in this area. Okay, so meet you soon in the next video, and watch the videos and don't forget to share. Okay. Bye.